Western Pennsylvania coal country. A pristine stream flows through a forested landscape.
Wait, pristine? The rocks are orange.
You know what? You're right. It looks like this stream has been affected by something called acid mine drainage.
Acid mine drainage. That's when water from abandoned coal mines flows over rocks producing acidic water. This releases iron into the stream.
And explains the orange rocks. The water in the stream is actually quite toxic, but what you see in front of you is only a small part of the story. There's much more than meets the eye.
In fact, there are processes in our environment that take millions of years to occur, as well as those that happen millions of times a second, all of which are related in some way to this scene. We just don't notice them.
But we need to understand them. So we're going to take a journey, looking at all the slices of time that go into this polluted stream.
On our journey, we will use these clocks to help us keep track of time. Each of them accurately represents time. Even the clocks that appear still are in fact moving.
While some are moving so quickly, they're blurred. Let's highlight the seconds clock. The seconds clock is rotating 1 revolution per second.
The microsecond clock is moving 1 million times faster. That's why it's blurred.
Nanoseconds. Each clock is rotating 1,000 times faster than the one before it.
Picoseconds. Femtoseconds.
And attoseconds.
This clock is revolving 1 trillion million times per second. That's a 1 with 18 zeros after it. That is really fast.
Now that we know about the clocks, we can begin our journey. We'll start by looking at the source of acid mine drainage pollution, the mineral pyrite. You might know this as fool's gold. It's common in coal country.
The breakdown of pyrite causes the pollution that we see in our stream. So what we're going to do is slow things down and take a really close look at how that happens. Here is the surface of the mineral pyrite, magnified more than 100 million times.
Over microseconds, we can watch the pyrite breaking down. In this time-lapse view, we actually see pits form and grow larger.
But to understand how the pits form, we need to look even closer. We need to see what's going on with the atoms.
And to do this, we have to zoom in again and slow down even more. We need to slow down another 1,000 times. Notice the changing clocks.
Here we're looking at a group of atoms. The red and white water molecules are attacking the surface of the pyrite.
It only takes nanoseconds to release an iron atom from pyrite. That's really fast, a billionth of a second. But because atoms are so small, this has to happen over and over to break down enough of the surface to cause the pits that we just saw.
If we slow things down another 1,000 times, we see the motion of water molecules around the pyrite. This motion, which happens over picoseconds, provides a constant supply of water molecules to attack the pyrite. Without this motion, the pyrite would stop dissolving.
At this point, we've already slowed things down 1 trillion times. But believe it or not, there are things going on here that are even faster. Let's focus on a single water molecule. We have slowed things down another 1,000 times to look at the motion of this water molecule. This is H2O.
The white hydrogen atoms vibrate around the red oxygen atom. The oscillation happens in mere femtoseconds, or a quadrillionth of a second.
Finally, we reach attoseconds, our fastest time step. We've now slowed down 1 trillion million times. Remember, that's a 1 with 18 zeros.
Electrons are swarming around an atom's nucleus. We're looking at the fundamental building block of everything, including you.
As we move back up to normal time, we are reminded of all these activities that go unnoticed, but still lead to our polluted stream. They just happen too fast for us to observe. Attoseconds, the motion inside atoms.
Femtoseconds, the vibration of water molecules.
Picoseconds, the motion of water around pyrite.
Nanoseconds, water's assault on pyrite.
Microseconds. Pits growing on the surface.
And finally, what we can see, the flowing of the polluted stream. But our journey is not over. We've only examined half of our time slices.
To know the full story, we must look at things that take place over minutes, years, thousands of years, even hundreds of millions of years.
But wait, most of these clocks aren't even moving.
They are. They're just moving very slowly. If we sat and watched this clock for 100 million years, it would go around only once.
That's a lot of sitting.
Sure is, but then we just need to speed things up so we don't need to wait that long. But before we do that, there's one more part of the story that we can watch at normal speed.
In just minutes, we can significantly change the Earth.
At this coal mine, they use a large dragline to get at the coal. This digging also uncovers pyrite that was formed along with the coal. And when that happens, the pyrite becomes open to attack by water and air. Modern coal mining operations like this one work hard to prevent pollution.
But in the past, coal mines were not as careful to prevent pollution from pyrite. That's why we have things like our polluted stream. Okay, so now we need to go faster. Let's speed things up about 100,000 times so we can watch what happens over years.
Once pollution is released, it can move quickly in streams, lakes, oceans, or slowly in water underground.
This red plume of pollution takes years to move through the ground. But even though it moves slowly, sometimes it can be a big problem because it's hard to see where the pollution is.
If we don't dig up pyrite, it gets uncovered slowly through the natural breakdown of rocks. This takes thousands of years to happen, so we need to speed things up again to actually see it. Over thousands of years, rocks break down naturally. This is called weathering.
Weathering starts at the surface and works towards the inside. Over time, the core of original rock is getting smaller and smaller. Though you don't see it here, pyrite minerals slowly break down with the rest of the rock.
We just saw how one rock breaks down. Over time, weathering combines with erosion to drastically change whole landscapes.
But this happens even slower still. Though this landscape seems unchanging, when we speed things up, we see that things really are changing as weathering and erosion carve the land.
Let's take a closer look now.
Great idea. That way we can learn where coal and pyrite come from.
But we'll also speed things up again because it takes millions of years for this to happen. Coal formation takes millions of years. Here we see a swamp where plants live and die, building up layers and layers of dead plant material. Over millions of years, drastic changes to the Earth's surface can cause the swamp to get flooded and buried.
Once it's buried, the dead plant material gets heated and squeezed, changing it into coal. And often, pyrite is formed right along with the coal.
We've reached the other end of our story. By speeding things up another 100 times, we can watch the entire surface of the Earth change.
Over hundreds of millions of years, the Earth's surface, which to you or me appears stable, changes dramatically. Watch how the continents evolve over time.
This is what we call plate tectonics, and it's responsible for the shape of the world around us.
We have completed our journey through time. As we move back to normal time, we are reminded of all the things that happen too slowly to notice.
Hundreds of millions of years, movement of the Earth's plates.
Millions of years, formation of coal beds.
Hundreds of thousands of years, the carving of landscapes.
Thousands of years, weathering of rocks.
Years, pollution moving through the ground.
Minutes, human changes to the landscape.
What seemed like a simple stream, we now know is much more complicated. It's a result of many things. Some too fast to see,
Others too slow to notice.
but each one of them critical to understanding complex environmental problems like our polluted stream.